Okay folks, here's a segment I've really been looking forward to. We're at Quantum Stabilizers in Fort Lauderdale, and we're going to learn about the principles of stabilization. Let's go inside, talk to John Allen, and see what we can learn today. Come on in, you guys. There's John now. Hey, John.
Hey, Paul. How's it going?
Really well. Nice to see you.
Yeah,
Thanks
pleasure.
for having us today.
Oh, thanks for
we
coming
really
over.
Appreciate it. So, what I was just telling the audience is today's segment on stabilization is really going to be about the principles of stabilization. Mm-hmm. Over the years, we've talked about many different types of stabilizers. We've kind of beaten the gyro stabilizer to death. It's a great,
why not?
It's a great unit and it has great applications. But the reality of it is, gyros is where stabilization really all began. It used to be the heart of the matter, wasn't it?
That's correct, yeah. And, the early fin stabilizer units that were built were all had control systems that utilized mechanical gyroscopes.
So it read what was going on with the gyro and it told the fins what to do. Now the gyro is actually the stabilizer itself.
Yeah, ironic, isn't it? Sort of
right?
a big turnaround. So, and actually it's even bigger than that, because if you think about, I think the 1920s or late 1920s, there was a couple of Italian cruise ships built with massive gyroscopes as a physical stabilizer, and then that sort of abated, and then fins took over, and they had a gyroscope that controlled the fin, and now we have gyroscopes that are actually back to doing the job themselves. So it's a full turnaround.
But the fin-type stabilizers that we use today aren't controlled by a gyro. That's all solid state now, right?
That's correct, yeah.
Okay, so it's all computerized. That's telling the motors and the control through the control boxes and the fins or whatever the stabilizing product or force is what to do.
Exactly, yeah.
Okay.
And there's many ways you can stabilize a boat for sure.
Okay.
But what's even better is this car. It's the only three-wheel car that actually is well stabilized.
It looks pretty stable to me.
It's very stable. It's a three-wheel stabilizer.
I like that. All right.
Exactly.
Well, we'll do the cars in another segment. Let's take a look at what we do here at Quantum, how we produce the stabilizers, what you do here, what do you do? Now you have another facility in the Netherlands, if I'm not mistaken.
That's correct, Paul. We do. We actually build about half the product here and half the product in Holland.
Okay.
So here in Florida, we build the hydraulic systems. They're the sort of main mechanical part that actually provides the energy to run the stabilizer.
Okay.
And at the shop in Holland, we build the actual stabilizer units themselves and the fins. And then we also have the entire control system. The control systems are complex. And the main part of the stabilizer control is built again in Holland. And then all the control for the power units, controls for the power units are all built here in Florida. So we're sort of like an international company in respect that the entire product is a combined effort of both here and Quantum in Holland.
Okay, so what we do with the stabilizer is we have a control unit, a computerized control unit that senses the movement of the boat.
That's
and
correct.
what it does is it tells the hydraulic pumps and the rams which way to move the stabilizing fins or rotors, as the case may be.
That is essentially correct. Yeah, that is correct. And that fundamentally hasn't changed from the advent of stabilizers. The control system tells the fins to move, the fins move, they generate lift, and they reduce the roll, or they counter the roll of the vessel. And that concept still exists today, but of course the control systems are not, gyroscopes and mechanical rods and linkages anymore, but they're, like you say, solid state and electronic. Okay. And the hydraulic systems are more advanced, and the foil designs are, more efficient and all these things, but in general, nothing's changed.
Well, let's take a look at some of the things that you build here. If I'm not mistaken, we have a test facility right here as well. Yep. So we can give a little sense of what we build here, what we go through to build these things. We'll take a look at the test facility, and then we'll take a look at some of the other parts of the facility here at Quantum.
All right, cool. So these are small power units here, and as you can see, they're gray, which generally indicates that they're not for a yacht.
Okay.
So these are sort of military.
Most of the yacht stuff is white. Right?
Yeah, exactly. Unless you're Roger Penske, then it would be red, of course. But,
there you go.
So anything that's built that's gray in color is a military application. And these particular units here are what we build for the US Fast Response Cutter. That's the FRC. It's a very well-known product now in the US. I think there's over 50 in service, and they're growing all the time. And these are just fixed fin, normal stabilizers.
So you guys build for the military. Is it just the Coast Guard, or do you build for the Navy as well?
No, we built for the US Navy and also many foreign navies as well. So that's quite a big part of our business. And then you see white equipment, and if it's white, then it belongs to a yacht. So this is, of course, that's a relatively small power unit. This is quite a large one. But in general, principles are the same. These larger power units have to have sound shields fitted to reduce noise, large cooling systems because they operate under quite harsh environments in terms of what they have to produce, their efficiency. They run at pretty much close to full capacity.
And what size boat with a system like that
So this power unit would go on a boat of, say, 65 or 75 meters.
Okay.
So that one unit would run the entire stabilizer package on, for example, a 65-meter boat.
And would that be a single set of stabilizers, or in some cases is it twin sets of stabilizers?
It would most likely in this application, if it's one power unit, it would be just 2 stabilizers or one pair.
So you have a separate power system
for each pair.
Set, but they probably would talk to each other, right?
Oh, absolutely. Okay. And then if the stabilizers get bigger, which they do, the larger units, then we have an individual hydraulic power unit for an individual stabilizer. So if you looked at, say, a 130-meter boat, where it would always typically have 4 fins, then there'd be 4 power units. And so each stabilizer unit becomes quite independent to itself. And what's really nice in the bigger ships is they dedicate an entire room within the ship just for the stabilizer. So there's each stabilizer, and if there's 4, you have 4 individual rooms on the ship, which are solely dedicated to that stabilizer unit and all its equipment that goes with it.
You've got a lot of equipment, you've got a lot of noise.
Yep.
Is there a lot of heat generated by it as well?
There is, yeah. So you have to abate the heat, and you also have to minimize all the noise within the system, because of course we know that it runs all the time, and it runs when people are sleeping.
And we've also learned, you know, in the boating world, we've learned that if you have the room and the facilities to have a dedicated room to a specific application, facilitates maintenance. It's easier to do maintenance, you're more inclined to do the maintenance, you do the maintenance properly, and it lasts for a lot longer.
That's true. So when we build the hydraulic systems here, they get built here, and generally they go directly to the shipyard.
Okay.
But before they can go to the shipyard, we have to test them and make sure they work. So we have a test facility here. It's a sort of a dedicated room where we can test hydraulic power systems and the controls that go with them. And we have a cooling tower and a water supply, so we're able to simulate the cooling system. And we have a load bank where we can actually create the load that the stabilizer would put on the hydraulic system.
Well, it looks like you can test any kind of system that's going to go anywhere in the world, no matter whether it's 50 cycle, 60 cycle, 3-phase, 4-phase, whatever the case may be.
That's it. We can run almost every voltage that we deal with, from 208 to 480, and we can run 50 or 60 hertz, however the case may be. So we're able to take the hydraulic system in its entirety and run it at full capacity and create all the conditions that we would expect to see on the boat. And that in itself is quite critical, because once the unit is installed in the boat and we actually go to commission it, we have very little time to actually correct anything that's wrong and get it running and do the sea trials. So we want to do as much as we can before the equipment gets to the shipyard.
Well, and it goes in as a unit when it goes to the shipyard as well.
Exactly.
And that way there's less opportunity for failure,
yep,
because it's been assembled, tested, and then shipped from here, and it's almost a plug and play type of system when it gets there.
Well, that's the goal. I can't say it's always plug and play. It's not a VCR, but or a Blu-ray player or anything else.
You and I remember VCRs and Blu-ray players.
Or an 8-track player.
There you go. Cassettes.
It's cassettes.
There you go.
So anyway,
these are valves here, right?
Yeah. So these are manifolds, and a big part of a hydraulic system is the manifold system.
The movement of the hydraulic fluid and where it goes.
Exactly, and we have to be extremely efficient about that. And the way to do that and keep efficiency, and also be able to design product-specific parts, is to do your own design work. Okay. So these manifolds, we design the manifolds, we do all the 3D modeling for the manifolds, and then we have them manufactured for us. So we're able to uniquely design for our products and not use equipment that's manufactured for other applications, and that's important.
Absolutely. So we've got yacht applications, we've got military applications. Looks like we've got a complete electronics room in there because it's not just a hydraulic system. There's an awful lot of electronics that controls all of it, correct?
That's right. So we have a lot of control work that goes into our systems, and the controls are often unique for each application. So that means that we have a job, it might be for a Fed ship or somebody like that, and their job could be different to a job that we might be building for another shipyard. Right. So our controls and our electronics engineers here at Quantum, they develop and design the control system, and then the guys here build it. And we write all our own code for our PLCs and programming, and that's all done.
Everything's
here.
Built right here in-house?
Yeah, all in-house.
Put together with machinery, sent into the test room, sent to the facility. The fins come in, or the rotors come in from the facilities overseas. They all meet at the yard. It's all assembled. Now, does the shipyard do the installation, or do you have technicians that go and do the installation?
No, we generally don't get involved in the installation, but we do provide like on-site support, for sometimes supervision, visits if they need. And if a part of our product has to be disassembled to be installed, which is not uncommon, then we'll go and facilitate the support for that and do the assembly on site.
If I'm not mistaken, we've got engineering, and we've also got some examples upstairs where we can take a look at how this stuff really works.
We can.
Let's
go
take
do that.
a peek.
Let's go check it out.
So, John, while we're on our way up to engineering to have a look at, I think you've got some 3D models of how some of this stuff is designed, and it'll give the audience a better idea of applications and what the products look like. You know, there's something that comes to mind. We've had several things that have really changed the yachting industry over the course of the last, say, 15 to 20 years. I would have to say that stabilization has become ubiquitous, because I remember in my days of running boats, we didn't have stabilizers. Some of the guys with the Hatteras motor yachts would have them. The bigger boats would have them. But what do you think is probably the one thing that has affected your side of the business more than anything else over the years?
Well, I think it's quite clear, and it's not just for me, but it's the whole industry, is the real game changer is zero speed. If you think 20 years ago, there was no, the word zero speed didn't exist. There was no stabilizer that worked at anchor, particularly. And boats were sort of...
Zero speed was an oxymoron.
Yeah, what was that? So that's the real game changer.
You know, I think you're absolutely right. We have a pretty active charter membership at IYBA.
Yep.
And I think you could argue that a boat without zero speed stabilizers is basically just not viable in the charter marketplace.
Yep.
In the boats over, let's say, 75, 80 feet. So what that has done is it has allowed the yachting community to not be reliant upon going to a marina every single night. It gives people more autonomy, it gives them more independence, it gives them the ability to cruise to far-flung places and still maintain perfect levels of comfort.
It is. And if you think about it, when we say it's a game changer, it's a lifestyle game changer, because, you know, as you and I both know, many of the owners of the large yachts don't actually travel on the boat. They travel to the boat when it gets to a location. Right. So their experience of the stabilizers was not really that great, because they were, you know, if they were underway, they made a small trip from one island to another, but they didn't make great passages. But now the stabilizers are unique to them, because it's a device that's operational all the time they're on the boat. And if it's not operational when they're on the boat, they may not be on the boat. Yeah,
right. That's why they have a Gulfstream,
big difference.
Or an AS350 to get them to the airport.
So it's sort of gone from being a product that was embedded in the bottom of the boat somewhere and nobody really knew much about it, to being a lifestyle product, because it affects the lifestyle of the people on board the boat.
So it's one of the more critically important components of the boat, as important as a fully rigged galley, important as a great entertainment system, as important as beach clubs and you know, dinghy garages and toys. But it's that product that is expected. It's got to work 24 hours a day, 7 days a week. It's got to be reliable. It's got to be quiet. It can't consume a lot of energy, because we have a finite amount of energy we can produce, and we have other systems that are going to put a demand on the boat as well.
That's true. That's true. It's a very, I think it's taken a big shift. Stabilizers, it's become much more front and center to the clients themselves, and you hear about it all the time now. When you know, and I say now, you know, over the last 10 years, when a client's signing for a new boat, you know, the actual client themselves or the wife might ask about, what's the stabilizers, how do they work, what kind of stabilizers are we getting? Well, 20 years ago, they would never have had that question.
Completely out of mind.
Yeah, it would have been out of mind. and they typically don't dive in and go, what kind of gearbox are we getting on this boat? You know,
what's the reduction on
what is that reduction on that gearbox? What kind of oil are you using?
Right.
But, you know, you mentioned stabilizers, and everybody, you know, looks around and, you know, they go, oh, well, of course we're getting, you know, whatever.
The best, whatever it is.
Whatever we,
right.
you know, whatever's in the spec.
And
but,
the fact of the matter is, even in the outboard marketplace these days, stabilizers are an important part of the conversation.
They are.
If we don't have it, I'm not going.
Yeah, that's true. And even when you look at Seakeeper and the small gyros that they make in that market, I mean, who would have thought, you know, 15 years ago, you were going to buy a 32-foot center console with a stabilizer in it?
That was absolutely
you
not
never
a part of
heard
the picture.
And yet it's, again, another sort of mainstream product now. So, so yeah, it's a game changer.
Yeah, it's a big piece of the puzzle. Yeah. So we're going to take a look at some of the 3D of the systems in their entirety, and maybe some fins and applications, and then we'll go into the training room, and we actually have some mock-ups in there of product that is for training purposes.
That's that we do, yeah. So we do have here. We try to design most of the stuff's all designed in 3D anyway. Okay. But we try to model everything, and we do the designs. So we do the engineering of what we're going to build, and then we send it out for manufacture. Okay. And this is something akin to the manifold that we were looking at a little while ago down below. Sure. So all this whole thing would have been designed, you know, by Kevin or one of the other guys here, and then they'll work through the process of it. It's unique to that particular product. There's nothing off the shelf about the design. We use, of course, components that are built off the shelf.
So this would be the exploded view of that manifold that we saw downstairs, or one like it.
Yeah.
And the oil goes in, the oil goes around, the oil comes out in whatever the controller tells it to do.
Exactly. So so all of our products like that are designed either here or in Holland, and they're all designed unique and specific to the projects themselves,
to the
application that we're working on at the time, which is critical. So anyway, and also we do our own controls design here. So not only do we do the mechanical design of the components and the hydraulic system, but we also work on the controls, the software, programming, and all the different applications, touchscreen design, graphics, and all those sorts of things. And all that's done up here, or at the shop in Holland, one of the two locations.
You'll outsource the hose, maybe the fittings, some castings and stuff, but all the bits and pieces are designed here for specific applications.
Here. Yeah, and so we're able to not only, you know, sort of simulate control technology like we would have here, so we can actually simulate a system working, but we also, so we have these, you know, sort of control systems set up which can replicate what the actual stabilizer is doing. So without actually being connected to a stabilizer, the control system can mimic what the stabilizer is going to do, and it can get responses back from these controls which represent what the stabilizer would be doing. So we're able to simulate as much as possible. I mean, ideally, when you build something, especially a company like Quantum, where we're forward thinking and we're constantly, you know, inventing or coming up with new ideas, you ideally like to beta test everything, and you want to go out there and you want to build a prototype and test it and then sell it. But it just doesn't work that way in our industry because we don't have a super yacht to play around with on weekends. So we have to, a lot of our testing is done in the field. We do as much as we possibly can here, or in the Marine, the model tank in Holland, or at the shop in Holland. But at the end of the day, the product gets integrated in the ship, and then we have to go to work on it. And almost all of our prototypes have actually, you know, ended up in a boat somewhere.
But your experience from one boat to the next gives you the foundation to be able to make your applications properly for the new designs that may come from Espen Oino or Cordova or whomever is designing, doing the naval architecture, and saying, okay, here are the specifics of the boat. Quantum, we need the proper set of stabilization for this boat. Your previous experience in other boats is going to tell you that you need to scale up, scale down, move it forward, move it aft, inboard, outboard, or whatever the case may be. Theoretically, to have the proper application. And it's through the engineering that you're able to determine that, because we don't have 300,000 units a year that we're building.
We don't.
We can do a couple of tests and then just replicate it time and time again.
Yeah,
everyone is different.
And you always want to, you always want to gravitate back to the things that you built before because you have experience with that. But our industry, you know, and probably much like other industries, is a forward-moving industry. So you really do want to continue to develop your product and improve your product, and that's it. That's
well, let's take a walk into the training room and let's see some of the products that you're talking about. There's one in there that's particularly intriguing to me because I think it's so innovative, and we talked about it a little bit more. We'll explain it some more, but on this, you know, in this sector, one of the things that we have that's really unique and unusual, and we don't think about it quite so often, technology moves forward based upon demand and based upon funding. And when you have large applications like nav systems for automobiles, or just let's think about the parking sensors. Well, it's really a transducer, right?
Yeah.
And transducers were expensive when we wanted to put them in boats. But when there's suddenly a demand for 12 million transducers per year, they figure out through economies of scale less expensive ways to make them.
Yeah,
but in our applications, the reverse is true. We have few of the units, but we have the resources. We have a demand from a public that is perfectly well suited to have whatever it is that they want, and they'll pay for it. And I'm not suggesting that what you build is expensive for any other reason other than the fact that it's very technical, it's very unique, it's very high quality, and we don't have these economies of scale to replicate it and drive costs down.
No, we don't. But what we do have is we have a client base that's prepared to invest in it, and they want to see new technology. So you often see this, and we see it in our industry and in our company, because we're sort of about 25% military. And for military applications, there's no possibility for development.
Right.
You can't go to the military and say, hey, by the way, we have this new idea, we'd like to try it out on the boat, it'd chase you out of the door. It's not going to happen.
Right.
But if you have a new idea in the private yachting sector, and you can prove it in some way, that, hey, this is something we don't have it in service, but we've tested it, and this is what it can do, there's much more interest in bringing that to market. So consequently, you do see our products and other companies' products much more advanced than what you'd see in the military application, because the military application is still working on specification from 27 years ago.
Right.
In fact, it's not uncommon to get, and we were talking about gyros and control systems, when you first came in. It's very, very common to see a specification out for a ship construction, a military warship, patrol boat, where they actually specify a gyro stabilizer control. And you have to go back to the, whoever's bidding the job, and you say, by the way, we don't make that anymore.
Right.
Nobody makes that. And they say, well, it's in the specification from 1963, we'll have to get an act of Congress to change this one,
Right.
So you sure you can't supply that? And we say, no, we don't make that anymore.
Can you find a guy from 1963 to build it for us? Right?
So that's really common, and you do see it. And the technical specifications are very fixed, and you have to adhere to them. So when you have something like that that's carried over from many, many years, eventually you have to talk the government or whoever's writing the spec to change gears or something like that.
One of the amazing and fascinating things about the industry that we have the pleasure of working in is that people of substance are willing to invest in these new technologies and investigate new technologies and try things based upon good foundational science and evidence, but they're willing to do things that really push the envelope, that really break the barriers.
Yep.
So what we've got here is a mock-up of a system installed in a boat, if I'm not mistaken.
Yeah, very similar. In fact, probably more, because we use various things for training up here. But we have represented as the mechanical unit, which is this would be the stabilizer.
So you would have actually a fin mounted on that shaft there on the outside of the hull.
So, but for training purposes, we don't need the fin, but we have the hull unit. And then we've made quite a few different control systems over the years. So we always maintain one or two, or in this case, 3 different control systems.
Right.
And we can turn any one on or off at a time if we're particularly interested. And we can also use this up here for ourselves for simulating things, like simulating a bug or something that we might have, where we can run the entire system. We have a frequency drive, we have a hydraulic power unit, and we have manifolds, and we even have a roll sensor here that's on a small table that moves backwards and forwards and sort of, it simulates the vessel rolling.
The movement of the boat.
Yeah. So we're able to do all of that from this, this sort of training setup here.
Okay.
And generally, when we do training, we can have generic training, which we do for some of the engineers on the boats, which is not uncommon. If it's a big boat, we'll try to tailor the training just for the system that they have on the boat. So we'll get rid of some of these components and only bring in the components that are relevant to them. Right. And then we'll do an entire training on maintenance and operation and things like that. And then we have other training, which is training for our own people, our own service engineers or technicians. And we try to have as much as everything that we can around, Say we could even look at a VFD that we wouldn't use anymore, but we might still do training because they're out there in the field and the service department have to deal with that. So we have to teach them about those things. So we use the training facility for lots of things, training the clients, doing military training, and then internal training for our own people. And that's very important. It's very important to, when you have technical products like these, and especially when you have products that are constantly in development and improvement, you've got to sort of bring the training to the front, and you've got to show people how it works, and especially our own people. Else, you're kind of in trouble if you can't support what you built.
You can't fix it.
Yeah.
But you bring a great point, and that is that it is a very complex and technical system, and it's not something that you hire a guy to go down in the engine room and just, there's the switch, turn it on, and that's it. He actually has to know how to operate the system, troubleshoot the system, maintain the system, because as we spoke about earlier, these boats go to far-flung places in the world, and if there is an issue, I mean, there's nothing that doesn't break, right?
Yeah, exactly.
So and that's another point that I'd like to talk about here in just a moment, and that is, how do we know if things are breaking? You mentioned to me earlier, before we started our segment here, that you have the ability to do some monitoring remotely if the client wants it through the system as it's built in, so that, let's say I'm in Tierra del Fuego and I have a problem with my port stabilizer on the boat. What do I do?
Yeah, exactly. Call somebody.
Okay, I got a problem with my stabilizer, John.
What do we do?
What's wrong with it? It's not stabilizing.
Yeah.
You're going to have to be more specific than that, Paul.
Yeah,
how do we figure that out?
Yeah, so it's becomes more and more unique, of course, because the products are more and more complex. And then they are more complex because we're trying to do more, we're trying to have a more efficient product that runs longer periods of time and it's quieter. And to do that, we have to, advance the product. And what happens is people, sort of get overwhelmed. They see the stabilizer, but they see all this equipment that goes with it, and and it's not something that they work on every day. That they're running the boat and suddenly it doesn't work. And for us, we don't always get all the information about what's going on. So we like the ability to connect to the system. And for some 10 years now, most of the systems that we built have a built-in internet access. We call it an E1 module. We built it into all the controls, and they just have to connect up to it. And once they're connected up to it, we have complete discovery within the entire system. So we can reach into the control, and then we can reach down to the stabilizer unit. We can even see this is an automatic greasing system. We can see what the greasing system's doing. We can take over the control system, which is here. We can start the system, we can adjust the system, and we can record data from the system. And we can do all that remotely. And that is absolutely critical. And for quantum, and especially in the most recent times, the last year or so, it's become quintessential.
Well, you can't even send a text sometimes.
You can't.
You can send a part and instructions on how to put it in.
Yeah.
But so it's key to be able to diagnose and troubleshoot the issue
all the time,
so that you send the right part and you get them back up and running.
Fast as you can. And in fact, recently we had a new boat was just being delivered, and they were in some quite heavy seas, and they'd reached out to us. There's no way we could have got to the boat, and anyway, not at that particular time in the middle of the ocean, but sort of in the middle of the night, we were dialed in and connected to the boat, and we were looking at what was going on, and we made some adjustments. We talked to the operators about it, and the system was up and running.
It was back
up and running. And we also identified things that needed to be corrected as well. So it's not like, we dialed in and pressed the magic button so everybody's happy and let's go back to bed, don't worry about it. It's never that.
You don't have a level button here at the office that just says, okay guys, let me reset the system.
Let's hang up. It's poor internet connection, sorry. But it's so critical. And that brings it all the way home. Is these boats aren't tied to a dock somewhere. They're all over the planet, and they're used to getting fast responses. You're used to jumping on the internet, typing a message to somebody, and you get an answer back. You get on a chat line or whatever. And for us, we would be slow to respond if we had to put somebody on a plane and meet the boat in Cartagena or something like that. And just to do that right now is almost impossible anyway. So to be able to say, okay, could you open up your internet access, which is there, they have the ability to do that. We can turn us on and turn us off.
Connectivity.
Yep. So they give us connectivity right here in this building, in our electrical engineering department. They can see the thing come live and they can dial straight in, connect to it.
And you've got dedicated secure servers. So the issues of someone getting into the system or doing something untoward.
Yeah.
It's a discrete, secure connection. It's used for the period of time that you're connected to the boat to diagnose, to troubleshoot, upload, download data, and then it goes off, and it's not something that remains as an open vulnerability source, if you will.
Yeah, that's correct. I mean, we all know nobody wants you dialing in when they're not looking at you.
That's another whole segment to talk about. That's exactly right.
But we did develop a system here where we use a dedicated server. So we have, I think, over 140 boats or something that we can connect to that are equipped for a connection. And all those modules on those boats can only respond to the one server. So you can't dial in from any other location. You have to go through the dedicated server. So we have a protocol for it. We developed it with our IT people here at Quantum, and we present that always to the clients and say this is how it works. But at the end of the day, they plug us in, they unplug us.
That's fascinating, and it also gives you the ability for product development as you go forward.
Yeah.
When you see maybe touch points that are ones that pose challenges repeatedly, or something that needs to be upgraded in your manufacturing and improvement of your products.
Yeah,
so
that's how you do it. It's feedback.
So this is something that fascinates me. Like I've said, I've been around this for a little while.
Yeah.
But the rotor stabilizer is a concept that I didn't understand well until you explained it to me a little earlier, and I would dare say that I'm not alone in the industry of not understanding it. Now, I happen to know a little bit about lift and low pressure versus high pressure and the Bernoulli effect, but tell us a little bit about what brought the development of the rotary stabilizer forward and where the application makes sense. And is it ever a hybrid application where you maybe would use this and fins?
Yeah.
Well, tell us about that a little bit.
So the Magnus effect, which is essentially what we're dealing with here, and this particular unit is one of the smallest that we've built, and it's sort of partially deployed at this time. Right. So normally it would drop down out of the pocket and swing out to 90 degrees to the hull side, but it's sort of partially retracted right now. Let's say it's stuck.
Right.
Anyway.
Well, we can dial into the engineering department and find out the problem.
See if we can get it fixed. Yeah.
There you go.
So anyway, we use a smooth cylinder. This is a carbon cylinder. I think almost all of the rotors that we built have either been carbon or GRP. This is a carbon cylinder.
Okay.
It's smooth. Often people think that it might have a rough texture, but it doesn't. There's no real difference between a rough texture or a smooth texture. And it rotates. And while it's rotating, if you pass a medium of air or water or any kind of medium over the surface of the rotating device, it generates high and low pressure. So the theory is called the Magnus theory. It's the same thing that we see with golf balls when they slice the ball and it climbs. That's the Magnus effect.
A tennis ball, when you hit it, top spin or which bottom, causes it to drop over the net.
So that in itself is the Magnus effect. And essentially this is what we do with the rotor.
So the rotational force causes it to curve,
it does,
if you will.
Yeah. So it has differential pressure across the surface. The faster you rotate the device, the greater the lift is, or the greater the differential pressure. So by increasing the RPM, we can increase the lift, and also by changing the direction, we can create the lift in the opposite
side of the
direction.
boat or the other side of the boat.
Yeah. So very much like a stabilizer fin, where we change the angle of the fin to generate more lift. With the rotor, we just increase the RPM.
Okay.
But the unique qualities of the rotor, apart from the fact that it's retractable, but the unique qualities is that it has a very high lift coefficient, and that allows it to create lift at slow speeds, where a fin would not particularly be in its foray of best performance. The rotor at the slower speeds, 7 to 10 knots or so, can actually perform very well. So by having a rotary stabilizer or a Magnus effect stabilizer, you can sort of open that the operational profile of the stabilizer system and have much lower speeds.
So this has a particularly good applicability to displacement boats, trawlers, if you will.
Yes, very much so.
Now, if I'm not mistaken, you'll also employ this system in combination with a fin-type stabilizer in larger boats. Is that not correct?
Yeah, that's correct. And
so how would that application play out? How would that work?
Well, if we talk about the Magnus effect, we start talking about it for a little while, and then you start to think, well, why would you have a stabilizer fin if the Magnus is so good? But there is no silver bullet. We all know that. And the Achilles heel to the rotor is that it doesn't perform so well at the higher speeds. So it's not a great
about
stabilizer.
10 knots is where it starts to lose efficacy.
Actually, they operate reasonably well to about 14 knots.
Okay.
But we, on our bigger units, we try to sort of curtail activities around 12 knots, and we start to retract around 14 to 15 knots.
Okay.
So if you've got a boat that has a normal cruise speed of 15 to 18 knots, then the Magnus effect alone would not be the stabilizer for that application. However, its merits are so high and it has so much potential in other areas that a combination of fins and the Magnus effect rotor is probably one of the best and most broad-reaching stabilizer systems you could have on a boat today. And that is quite common on boats in the sort of 80 to 120 meter range.
So in the bigger boats, we may have a set of rotary stabilizers aft.
That's correct.
And the fin stabilizers forward.
Yep.
And at slow speeds, we'd be using the two of them. What about in a zero-speed application?
So the zero-speed application, the rotor actually rotates in one direction only, and then the entire device swings underneath the boat through about 120 degrees. And so by swinging the rotor backwards and forwards, we're able to generate lift, we can generate flow over the rotating cylinder, and then we can get the lift back. So we have a great zero-speed application. It can work in conjunction with a standard fin or an XT fin. We have a great slow-speed application. And also, the rotor is less inclined to suffer from the effects of heavy reversing of the ship or anything like that. So we can actually keep the rotor active in its zero-speed mode up to about 3 knots, and then automatically we can switch into the underway mode. So it can be quite automatic when it transits from its operation in zero speed to its operation underway. Unlike a fin where when we get over 3 knots, the fin sort of parks itself, and then once the speed increases, then the operators have to restart the fin or turn it back on. So.
Now you mentioned an XT fin. That's an innovation of yours, if I'm not mistaken.
That's right.
Where the center of the fin actually extends down. So if I'm not mistaken, it's 30% more surface area, but 100% more efficacy.
It is, for zero speed. So the XT fin was another sort of landmark device for us, I think in 2005 when we filed the first patent on it. The idea was that for zero speed, we needed larger fins than we needed underway. And we were sort of novices in the zero speed game back then. There was not that many systems out there.
Everybody was.
Yeah, we were just developing the thing. So we thought the concept was that how could we make a larger fin when we were at zero speed, but have a nice and more practical fin for underway when the boat's underway. So we came up with the XT design. It's really been the standby of everything we've done. I'd say that it's sort of eclipsed even standard fins for us now, and almost everything we sell is an XT. But you're correct, we have a foil that's located inside the main fin, and we deploy it, and when we deploy the foil, it increases the fin area for zero speed.
And all of that is on your website?
Yeah.
On quantum.com?
quantumstabilizers.com.
Quantumstabilizers.com.
Yeah.
And you can see the rotary, you can see the XT, you can see exploded views of the systems, you can see explanations, the physics, the science, the theory, the reality. That's fascinating. I think this is a completely different look at stabilization than we've had the opportunity to have before. I really appreciate you taking the time, John.
Yeah.
I think that's all the time we have in this segment, but it was fascinating. The audience can ask their questions in the chat room, and you can also go to quantumstabilizers.com or watch this video again on iyba.org on the events folder. Thanks for joining us, and now we'll go back to a commercial break.
Yacht Engineering Week 2021 has been made possible by Pantropic Power, the only authorized Caterpillar Power Systems dealer in South Florida. Florida Nautical Surveyors, your complete solution to all of your vessel surveying needs. And Robert Allen Law, exclusively dealing with the business of yachting. We would also like to thank Quantum Stabilizers, AME Solutions, DeAngelo Exhaust, MPI Marine Professionals Incorporated, Concord Marine Electronics, Lauderdale Marine Center, Marine Data, Isotropic, Dockmate, and Murray Ventilation Products. Thank you for joining us this year. We'll see you in 2022.